All right. Good evening. It's been 5 months since I last worked on using this chip. I still feel like a beginner. Anyway, one thing I was wondering is, here you have the working register being loaded up with a value, and then the very next line of code is just there. It doesn't have a move working register to file command. It skips that. It just has the option file register mentioned. Likewise, the trice register appears much the same way. There's no move WF trice. And you think I would know more about that, especially now that I've created 20 different videos on the PIC10F200. You would think I would know why it's permissible to skip a move WF opcode. It also begs the question as to how, when I originally wrote much of my code, I knew to skip writing move WF. Granted, I have borrowed sample code from all over the internet. When I originally started creating these videos 3 or 4 years ago, ChatGPT was not available. At least I didn't know about it. But now ChatGPT is available, and you can ask it such questions. So I won't be too proud to rely on this type of source. Some people might like to hide the fact that they asked ChatGPT a question. They might just like to show their audience that they were omniscient and they already knew everything there is to know about PIC programming. I'm not that arrogant. I am a little bit, but not that arrogant. So anyway, I am going to make use of ChatGPT. These videos are really like memoranda for myself. They're not really structured and designed properly for entertainment or for viewers coming along. But I do hope that my videos help people, and I do hope people enjoy watching them. Maybe people have a laugh because they know much more than I do. Very possible. Well, without rephrasing it again, I asked ChatGPT why this move WF command gets omitted. I'll read what it said so I don't paraphrase it wrong. In the PIC10F200 assembly language, the option instruction is a special case. Unlike most other special function registers, which require a move WF instruction to move the value from the W register to the target register, the option register is accessed directly by the option instruction. When you write the option instruction, it implicitly moves the value from the W register into the option register. Therefore, you don't need an explicit move WF instruction. This is why you see the syntax used in many code examples. Here's a breakdown of my code. In this case, the option instruction itself performs the action of copying the value from the W register to the option register. This is specific to how the PIC10F200 handles the option register, making the code proper and correct. If you want to confirm this behavior, you can refer to the PIC10F200 datasheet, which describes the option instruction and its usage. Okay, ChatGPT doesn't get things perfect, and I won't digress on that. It's pretty good, and I tend to trust it. It's good for a good opinion. Anyway, I'm looking for instances in the datasheet where it talks about the option register, and particularly where it says you don't have to, I want to choose the right words, where you don't have to use the move WF opcode to move the working register into the option register. Well, I haven't found where it explicitly states that, but just as an example, in this piece of code, it actually shows that's being done here as well. There's no opcode preceding option. Here is the answer right here. By executing the option instruction, the contents of the W register will be transferred to the option register. Somehow I missed that. Alright, the rest of this video is going to be a learning video where I gather all of the information related to the option register, timer register, and prescaler. I'm going to try and stick to those things. Option register, page 16 of the datasheet. The option register is a 8-bit wide write-only register which contains various control bits to configure the timer 0/WDT watchdog timer, prescaler, and timer 0. By executing the option instruction, the contents of the W register will be transferred to the option register. A reset sets the option 7 to 0 bits. Note, if trice bit is set to 0, the wake up on change and pull up functions are disabled for that pin, i.e., note that trice overrides option control of GPPU and GPWU. These two. If the T0CS bit is set to 1, it will override the trice function on the TOCKI pin. Here is the special function register SFR summary, and it says the trice register is on page 31. No, must have got that wrong. Alright, so I spent about 5 or even 10 minutes looking up the trice register to find out, well, what's this trice bit? No, it's just talking about the trice register itself, which surprisingly the datasheet does not present the trice register in a format like this. It appears on page 20, and it has this chart which isn't quite the same. And I read this and this. But all this means is that if you set the trice register as outputs or inputs, it's going to override the functions of these GPPU and GPWU. I'll start with GPPU, and this is just based upon my own logic. I could be wrong about some things, but this is to my best judgment. The GPPU bit 6 in the option register enables weak pull-ups, which are on GP0, GP1, and GP3. And I believe pull-ups are specific to input pins. So if you want the pins to be normally held high and perhaps triggered by a low signal. Interesting, there's no pull down bits, but whatever. So I guess if you use the trace register and set any of these pins as output, except GP3, which is input only, if you set, say, GP0 and GP1 as output, I suppose it overrides whether or not you enable weak pull-up resistors, which really apply only to input pins. And that's kind of what it says. If trace bit is set to 0 as an output, the wake up on the change and pull-up functions are disabled. I don't know enough about the wake up pin. I've never studied it enough. But I'm assuming that a wake up pin could only be an input pin when you wake it up from sleep. So once again, if you set the trace register bits to 0, it'll override if you set particularly these two pins as outputs. Okay, I'm going to be all over the place. The GPPU enable weak pull-ups bit 6 pin in the option register that enables the weak pull-ups. Let's investigate that one. And by that I mean, how many times does it show up on the find in a datasheet? Okay, first instance, it shows up on the SFR summary. It shows up in the option register, which we're reading. It shows up here, here. Summary of port registers. I guess the option register shows up in this section. Registers associated with timers. It shows up, the option register shows up here. And it shows up in the summary of registers associated with the watchdog timer. I'll do a cursory search for the GPWU. It shows up 23 times. It shows up in the status register, believe it or not. Kind of. GPWUF. Well, I don't know if I'm going to cover all the instances of the GPWU. I don't really plan on using the wake up thing. I'm not designing a commercial product. So now we're talking about the option register still, and there's a note: if the TOCS bit is set to 1, it will override the trace function on the TOCKI pin. So I better look at the TOCS pin, which is bit 5, timer 0 clock source bit. Transition on TOCKI pin overrides trace on the TOCKI pin. 0 transition on internal instruction cycle clock. I don't want to risk putting an error in my video. Probably do that enough. But the TOCKI function is related to pin 3. Alright, so this bit 5, TO clock select, timer 0 clock source select bit, if you write a 1 to it, you write a 1 to this one, a transition is on the TOCKI pin. Overrides trice on the TOCKI pin. Or the transition is on the internal instruction cycle clock. I am just guessing. I don't know this. But I am wondering whether the clock source can be 1. An external clock source, which is picked up as this GP3, I guess. GP2, but it's on pin 3, is set as so I have to emphasize because I just said it wrong. GP2 can be set up as a TOCKI pin. So I will speculate what I think is probably true here. That GP2, emphasis added, GP2 can be set up to take in a timer source, or if you set this bit in the option register as a 0, the transition for the timer 0 is on the internal instruction cycle clock. And once again, I will read this note as it pertains to bit 5. If TOCS bit is set to 1, which maybe is an external clock, it will override the trice function on the TOCKI pin. Well, I had problems in the past with GP2 not working when I tried to use it as an output. Could it be for this reason? I mean, after all, I was sticking this line of code in some of my code. Enable GPIO2. Well, this is so written in such a weird way, I forget what this even does. I mean, I know it toggles the bit, but I don't know whether it's on or off. I'm just going to go off on all kinds of different tangents. So I asked, please tell me about what this line of code does. Move literal value to the working register tilde 1 pointy TOCS enable GPIO. Let's break down the line of code thus and understand its purpose. Code analysis. TOCS macro or definition. TOCS is likely a macro or constant defined elsewhere in your code or in an included header. No file. It stands for timer 0 clock source. Typically, TOCS is defined as 5, corresponding to bit 5 in the option register. Bitwise operation thus shifts the binary value 1 left by the number of positions specified by TOCS. If TOCS is 5, then this is 1, 5, which equals 7, 6, 5. It sticks a 1 there in binary or 0x20 in hexadecimal. Bitwise NOT operation. The tilde is a bitwise NOT operator which inverts all the bits of the operand. Applying this to this results in this in binary or 0xDF in hexadecimal. Move LW instruction. Move LW moves the literal value into the W register. Move LW tilde this moves the value this into the W register. Explanation in context. Move LW thus enable GPIO2. This line of code performs the following actions. It calculates the value of this by shifting 1 left by 5 positions. 1, 2, 3, 4, 5. I guess it sticks a 1 here, and then inverting all the bits. It loads the W register with this value. The comment, enable GPIO2, indicates that this operation is part of the process to enable GPIO2 specifically. The TOCS bit 5 of the option register, is set to 0, meaning the timer 0 clock source is set to the internal instruction cycle clock. By loading the W register with this, you ensure that when you write this value to the option register, you clear the TOCS bit without affecting other bits. Example usage. Here's how you might see this in a larger context. Move thus, load W register with this to clear TOCS bit, copy the content of W register into option register. By executing these instructions, you ensure the TOCS bit is cleared, enabling the internal instruction clock for timer 0 and potentially configuring GPIO2 for use as a general purpose output. If you need to ensure GPIO2 is an output and control its state, you'd also include setting the trace register and writing to the GPIO register as needed. Well, I always confuse myself reading this stuff, but okay, so if you did that, you're not just affecting the GPIO2 bit or this TOCS bit 5 of the option register, you're actually affecting all of the other bits too, because you're loading the W register with that. So is that what you would want? 1, 1, 0, 1, 1, 1, 1, 1. What would you do if you did that? What would you be doing if you did that? You'd be setting the GPWU register as disabled. That's not so bad. You'd be setting the weak pull-ups as disabled. Not the worst thing, I guess. You'd be setting the transition to the internal instruction cycle clock, which I think is probably what you would want, because most likely you're not going to use this TOCKI pin, which is GP2, for an external clock source. I think that's what that does, but I shouldn't say that out loud because I don't know. TOSE, timer 0, and then you're setting the rest of the bits as 1s. So you're incrementing on a high to low transition. So when something goes low, the falling edge. And if you're setting the prescaler to 1, 1, 1, well, what does that do? I kind of forget now. You're setting the timer rate to 1 to 256, or the WDT rate to 1 to 128. Okay, for future queries, how would I want to set this up? GPWU, the wake up. Yeah, I disable the wake up. Don't really ever plan on using it. The weak pull-ups might be useful. Depends on if I'm doing an advanced circuit. At this point I'm not. So we can disable the weak pull-ups. I could use, if I was going to do a circuit anyway, I'd probably have some pull-ups anyway if that's what I was doing. TOCS timer, clock source. Yeah, I'd probably be wanting to use the internal clock source. I'm not going to give up a GP2 to have as a clock, if that's what I think it does. So I would probably have bit 5 as transition on internal instruction cycle clock. TOSE, timer source edge select bit. Once again, we're talking about this GP2, assuming you're setting it up as a TOCKI pin. And then I guess this TOSE, TOSE bit 4, timer 0 source edge select bit, would be selecting whether we're incrementing from a high to low transition or a low to high transition. However, if we're writing if we're using the internal clock and not using GP2 as a clocking pin, then it probably doesn't matter what you put for bit 4. It could be anything, really. So it probably doesn't matter. And I haven't experimented or read the section of the datasheet which relates to the prescaler yet, so I don't know. What would I write to that? All ones, all zeros? Not sure yet. So I guess we could write bit 4 a 0, because it doesn't matter since this is a 0. And the prescaler, I don't know, what this piece of code was doing was pretty much this. In the PIC10F200, what does the TOCKI pin do? In the PIC10F200, the TOCKI pin serves a specific function related to timer 0. Here's an overview of what the TOCKI pin does. TOCKI pin, timer 0 clock input. The TOCKI pin is an input pin that can be used as the clock input for the timer 0 module. That's what I suspected. Here's a detailed explanation of its functions and how it works. Clock source for timer 0. The TOCKI pin can be used to provide an external clock source to timer 0. When timer 0 is configured to use an external clock, pulses on the TOCKI pin increment the timer 0 counter. Configuration via option register. The usage of the TOCKI pin is controlled by the TOCS timer 0 clock source select bit in the option register. TOCS 1. Timer 0. Once again, we're in the option register. The TOCS bit is the timer 0 clock source select bit. Setting it to 1, transitions on the clock pin, or GP2. I'm surprised it doesn't say GP2. 0 uses the internal instruction cycle clock. What was I here? I'll just read. The usage of the TOCKI pin is controlled by the TOCS timer 0 clock source bit in the option register. TOCS equals 1, timer uses the transition of the TOCKI pin as the clock source. TOCS 0, timer 0 uses the internal instruction clock cycle as the clock source. 3. Pin function multiplexing. The TOCKI pin is shared with GPIO 2 GP2. When the TOCS bit is set to 1, the pin functions as TOCKI. When the TOCS bit is set to 0, the pin functions as a general purpose IO GPIO2. Example usage. To use TOCKI pin as an external clock source for timer 0, you need to configure the TOCS bit in the option register to select the TOCKI pin as the clock source. Ensure the trace register is set to configure GPIO to TOCKI as an input. Example code. Here's an example of how you might configure and use the TOCKI pin. Configure GPIO to TOCKI as input. Bit set F status RP0. Well, there's no bank switching in this chip. BSF trace 2 set GPIO 2 as input. In this old piece of code, actually, it's setting GPIO 0, 1, and 2 as outputs, and 3 as an input. This code uses GP2 as an output anyway. But in this case, I guess if you want to use that TOCKI pin, you're going to have to set GPIO2 as an input. This is like bank selection, which I don't think is related to this chip, although it might be in bank 0 for sure. I know the status register in the 16F series has a bank select in the status register, I think, if my memory serves me correct. Select TOCKI as timer clock source, move LW. So what's it doing here? It's setting this timer clock source as using that TOCKI pin, so it sets bit 5 to 1. So it sets 0, 1, 2, 3, 4, 5. It sets bit 5 to a 1, which selects, or it sets the TOCS bit in the option register, which makes this TOCKI pin an input TOCKI pin by giving it a 1. And who knows what it's thinking, but it's actually enabling the wake up. Or no, it's enabling the wake up and the weak pull-ups. Maybe it doesn't really know what it's doing. But then it's actually giving this a 0 increment on low to high transition. Okay. And then the bit 3 prescaler assignment bit, you can assign it to the timer 0 or the watchdog timer. Oh, okay. I didn't cover that before my last part where I was conjecturing. And yeah, maybe that would actually be good to set that to 0. Yeah, assign the prescaler to the timer 0. I don't ever want to use the watchdog timer, really. And then in this ChatGPT example, it's suggesting the rate is 1 to 2 for the prescaler. Now timer 0 will increment on each pulse received on TOCKI pin. Well, that's interesting. That's actually something to consider for later if I want to set up a 555 timer, hook it up to the TOCKI pin, and see if I can get that pulsing. And potentially I could use an external clock source as a delay. And I wouldn't have to write a delay into the code. And I'm actually always looking to do stuff like that, is to create a circuit around the chip which can make use of external circuitry to maybe give a delay. That's neat. Important notes. Edge detection. Timer 0 can be configured to increment on the rising or falling edge of the TOCKI pin signal by setting or clearing the TOSE bit in the option register. TOSE equals 1, increment on the high to low transition, falling edge. TSO equals 0, increment on the low to high transition, rising edge. Prescaler. The prescaler can be assigned to timer 0 to divide the input clock frequency, which is also configured via the option register. Pull-ups. If the weak pull-ups are enabled, they can affect the TOCKI input so ensure they are appropriately configured for your application. Yeah, that's a good note. Yeah, I don't want to think that one through, but that's kind of important if we're going to use the TOCKI pin. Using the TOCKI pin allows timer 0 to count external events, making it useful for applications like frequency counting, event counting, or generating time delays based on an external clock source. Well, that was my idea.